So the first thing I have written here is these definitions of the idea of finite and infinite, okay? And infinite means forever, or it goes on and on, right? And finite means that there's an end, okay? So they give us like this is set notation. These are braces, okay? Not like for your teeth, but for numbers. Okay, so if they give us a set of numbers, which they did, they gave us 6, 7, 8, 9, and 10. We are calling this a finite set because it has a starting, it has 5 members, right? Sorry, you can't see that. It has 5 members to that set. Now, if I wrote this instead, oh, that's a horrible brace. If I write this instead, 1, 2, 3, 4, and dot, 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 okay? That symbolizes the idea that this goes on and on forever, okay? So it's got an infinite number of members, okay? Finite amount of members, infinite. So that's pretty straightforward. The dot, 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 most of us are all, there should only be 3 dots, familiar with. That just means it goes on and on forever, okay? So those are the 2 vocabulary words that they gave us. Now, we're going to talk about some other things about set notation. If we wanted to designate a set, we want to designate these members, or these numbers, as members of set B. We would say B equals the braces, and the members of this set are 0, 1, and 2. And then you close your set. So that's set notation. Okay, so example 1, it says represent the following numbers. As members of set K. Okay, so this is example 1 in your book. So we're going to represent these numbers as members of set K. So we do K equals, and all right, we have a bunch of repeats, right? So we have a 0, we have a 1, we have a 2, we have a 4, a 5, and a 7. Okay, so that's how we would answer that question. Okay. There's also another one that I'm not going to do, example 2, and they talk about just making another set of numbers from, or members of a set, just like that. So not much is different. You can look at that yourself. I would encourage you to do so. Okay, example 3 gave 3 sets, A, B, and C, and hopefully you're looking there. Okay, so we've got members of A, B, and C. The question says, for A, part A, tell us which is true, okay? And they've got these weird symbols, okay? N is 4, and I will just teach you how to read those. Okay, so what they're asking here is 5 a member of A? Well, we look up there and it is, so we say true. Okay, so that means an element of or included in set B. So is 4 included in set C? So we look over there and I do not see a 4 in the members, so that would be false. 4 is not a member of set C. Okay, then is 5 not a member of set B? So, yep, that's true. I don't see 5 in there, so we'd say true. Okay, so then they also have another example, example 4, given a bunch of sets, and go ahead and read that. Okay, you got set L, set M, and set N, and they're asking the same kind of questions as these. Okay, it shouldn't be too terribly difficult. It's just different because you guys aren't used to doing set notation, so that's new. So now we are talking about graphing. They say to graph 3x plus 2y, and I have this in your notes, equals 4, okay? And I made one of those T-charts, but it's a little different. It's horizontal. Okay, remember when we did this? We have this, and we are going to make a t-chart for it. However, first they take this equation, and it would be good to isolate by getting y by itself, okay? And the reason we want to do that, it'll be easier to make it more convenient to do the table, okay? Because again, remember how we did this? We were like, okay, how about 0, 2, and -2 are always good ones to try. Okay, so let's first get y by itself. So we're going to subtract 3x from both sides. Now, 4 can't take away 3x. These are not like terms, so they're going to have to be next to each other. Okay, like that. And I always start with the x first. And then 2y is here. So y is almost by itself. We've got to divide by 2. We have to divide everybody by 2. Don't forget that. All right, so when we do that, that reduces to just y. That reduces to -3/2 x, and that reduces to 2. Okay, so now we've got this equation, and we're going to use this chart. So when x is 0, if we plug 0 in here, we get y equals -3/2 times 0 plus 2. I know you can't really read that because it doesn't really matter. That just turns into 0 plus 2, or y equals 2. Okay, so when x is 0, y equals 2. So we have that. And then if we do the same thing for 2, plug in, we've got y equals -3/2 times 2 plus 2. Okay, hope you're with me on that. Can always stop, pause, rewind, and rewatch this. Okay, now notice I always like this because these actually will cancel out. This, if you think about it, is up high, and so they cancel each other out. And now we have -3 plus 2, okay, which is -1. So that goes up here. All right. And I'm going to erase, make room for the last to do -2. So now we're going to do y equals -3/2 times, here, I'll put it up here to give you a visual. Okay, plus 2. All right, now these two cancel out, but don't forget we have a negative times a negative. Okay, so the 2's go away, but that still is a negative times a negative, so that turns into a +3 plus 2 equals 5. Okay, so then we get to put 5 in that box. All right, now I'm going to pull some graph paper over, or my graph whiteboard, okay? And I'm going to write on it our ordered pairs. We have 0, 2, 2, -1, and -2, 5. Okay, that's what we got from our chart. So if I go ahead and take those 3 points, Cartesian plane, so 0, 2 would be 0, up 2. Take a while until you guys get used to knowing that you go right or left first, and then up or down. So 2, -1 means coming over 2, down 1, and then -2, +5 would be up here. Okay, and as you see there, we have a nice straight line, and I do like it when we use a straight edge to connect our dots. Okay, to make a nice line on your graph paper, I'm hoping. Well, I'm requiring you guys to use graph paper. So, you're going to be attaching another piece of paper to your notes this time. And there you go. There it is. Okay. Now we're going to graph the next one, which is example 6. It says to graph y minus x equals 0. Okay, just like before, they say that it'd be better to get y by itself. So if we add x to both sides, we have y equals x. Look at that. Okay, Now you might get used to, most of us in advanced math know what the line y equals x looks like without having to do any graphing. And we will show you, this is, every time you get y equals x, it's always going to look exactly the same. Okay, so if we, here's a nice thing, we don't have to do much math to make the chart, right? So if we do it vertically this time, again, it only takes two points really to make a line, but just to be really careful, it's nice to have 3 points. Okay, so when x is 0, y is 0, right? Because they're the same, y equals x. When x is 2, y is 2. When x is negative 2, y is negative 2. Okay, so you can see a pattern there. Okay, so let's go ahead and graph those points on your graph paper. Okay, so I'm going to switch that out. The book used 0, 3, and negative 3, but it doesn't really matter. Okay, so we did 0, 0, and we had 2, 2, and we had negative 2, negative 2. Okay, and you see what's happening there? The line y equals x will always look like a perfect, sorry, this is a little difficult. Next time I'll bring a straight edge to my classroom. Okay, so as you can see there, it's perfectly in between. It cuts this quadrant perfectly in half, and it cuts this quadrant perfectly in half. This will always be the graph of y equals x. Okay, so you have 3 practice problems.